for this recording, my name is Gray, Gray Lovelace. This is Source Allies, talking about Spring Boot. So this is a base level intro to Spring Boot. It's going to be fairly discussion based here. We're not going to do a lot of like really digging deep into specific topics as part of this initial part that I'm going to go through, but I'm going to open it up for questions fairly soon here, and we'll just download a project, start coding, and then if we want to explore a certain subject, let's just explore it together. I might know how to do it. There might be someone in the room that knows how to do it already, or we might just all learn something at the same time, or completely not learn something at the same time, which also happens. So starting out, what's Spring Boot? You have heard some very smart people the last couple of sessions talk about what's Java and like what's going on in that space, which is great. Spring Boot is kind of an answer to a problem that enterprises created for themselves, which is the monolith. You often hear Spring Boot talked about in the same breath as the word microservice. And regardless of how you feel about the word microservice or whatever like size of service you're talking about, that's at least part of why you hear a lot of people talking about Spring Boot. They're like, hey, what is a really easy way to get my app up and running and start delivering some kind of business logic quickly, where I don't need to go like package up my logic with a bunch of other logic that already exists just so I can use the same build pipeline, the same server, the same all of this stuff that has existed forever, and I get out of the box by just checking this code into a monolith that's already out there and has its own life cycle. So Spring Boot is a framework, basically. It is a Java framework. Technically, it's a JVM framework. There are a couple of other languages you can use it with that I will get into later. But it is, we'll go into more detail about like technically how it's working, but as a snapshot, let's just walk through some of these. It's framework. The goal, if you go visit just the Spring Boot documentation and the Spring Boot website, is to be able to easily create standalone production grade Spring-based applications that you can just run. Yeah. There's some funny things in there, but one thing I want to pick apart is that it says production grade Spring-based applications. You're like, oh, Spring? Isn't this Spring Boot? Like, obviously it's a Spring-based application. That's what Spring Boot is. Yes, but Spring is technically an entity apart from Spring Boot, which seems fairly obvious to people who have been in the Java space for a long time. But if you're coming into the Java space within the last few years, you probably haven't used Spring out of the context of Spring Boot almost at all. So Spring has a lot of Java libraries that they used to create some things we'll talk about more in the tech space later on. But just realize that especially in enterprises, Spring as a concept and as different patterns and libraries was being leveraged long before Spring Boot ever became kind of the encompassing framework we're using to actually put all those things together. That makes sense? Sean, what's up?
Well, I was just going to add that your bullet point about opinionated sensible default. Spring by itself is the exact opposite.
Yes, correct.
It has zero opinions and no sensible defaults. You have to configure it.
Yep. Yeah, so perfect. Next bullet point, opinionated sensible defaults, auto-configure resources whenever possible. You will find, and we will talk more in a little bit about Spring. Basically, all it's doing in all of the different libraries that you're getting when you use Spring Boot are spinning up a bunch of different resources that throws in the bean pool, which we get to dig into later. And the bean pool contains all of these different resources and instantiated classes that you're going to work with. Spring Boot specifically tries to build all of those without any input from you, but allow you a very easy way to override all of those defaults, which I think is the sweet spot. I've worked in some frameworks where it's like, hey, we're very opinionated and you need to follow that opinion, and that's the only way forward. And then I've worked in other ones like raw Spring without Spring Boot, where it's like, hey, we're going to let you do all this stuff, but you have to determine how everything works. We're not going to make any assumptions. We're not going to like do anything by default unless you specifically ask us to. to me, this is a really nice happy medium that I enjoy working in. Some people aren't as happy with it, but that's yeah. Okay, so opinionated sensible defaults. The other part that is a big departure, if you've just worked with Spring or you've worked with Java in the past, is that there's a built-in server. So for normal Spring Boot, I believe it is Tomcat still, which is an Apache server. If you use reactive Spring, which is kind of a different version we won't get into a lot today, probably, it is a Netty server or a Jetty server. And then there's a couple of other options you can dig into. I believe I've really only ever used the Tomcat and the Netty versions before. But outside of the Spring Boot ecosystem, if you are building a Java project, you need to basically have a server that you are serving that up on. In the past, that looked like having this server that was installed, like server software that was installed on different machines. Like I had to work with IBM WebSphere a lot, which was a pain. But that is the ecosystem that you were living in for a long time. The code and the thing that was serving up the code did not live together and did not talk to each other that well. You managed them as two completely separate entities. And when you were like running your code, you were not running it on the same type of server as it would be served up on in an actual environment, which, yes, did lead to problems, if you're wondering. So this is a kind of shift in that paradigm in the Java world. And then the other things that I really enjoy about Spring Boot, but they also call out in some of their documentation, is it's not code generation based. I see a lot of different frameworks that say they're frameworks, but they are really more like templating engines. I'm not a huge templating engine fan because you make it once and then you're stuck with whatever snapshot of that you generated that with, and now you're coupled to that code instead of being able to like switch out a library that's doing that stuff. Spring Boot is all library based. It's all doing that resource management stuff in the background I was talking about. It is not generating code for you to stick in your application as a templating engine. Last thing before we start digging into more technical topics, very, very robust ecosystem. That's probably why Spring Boot has lasted longer than any other framework in that kind of space. I think anyway, it's the one I've used the most. There are just so many different plugins either provided by Spring or things that work natively with Spring that are allowed. So any questions on any of that before we go into a little bit of like how Spring Boot works or some patterns you kind of need to know if you're working in that space? All right, let's do it. Yeah, and the owl is only showing me like one person at a time. So if anyone has anything to say in there, feel free to just jump in.
Will do.
Cool. All right. So what the heck is a bean pool is an excellent question. I realize I should talk about this because I have done mini Spring intros for different teams and gotten 45 minutes into it. And then someone's like, hey, what is a bean and what is a bean pool? And that's a really great question. So to be honest, like I don't know 100% where it came from, but Java is basically coffee. Coffee has beans. So often you will hear an instantiated version of a Java class referred to as a bean. A bean pool is a pile of those beans. Really, it could be called a bean pile, and I think it would be just as effective. But that is what a bean is. It's just an instantiated Java class. It's not anything more special than that, unless anyone else in the room has any thoughts around like what differentiates a bean from just any old kind of instantiation.
There's a thing called the Java bean specification.
Mm-hmm.
And what that is it is the spec that says that it's a specification for getters and setters. So it's saying if you want to expose a property of a bean of a Java class,
Mm-hmm.
you expose that by using that convention of like get space property name, where the first letter of the property is uppercase,
Mm-hmm.
with the exception of Boolean properties, which could be is followed by property name uppercase, and corresponding set. That syntax, so saying I'm going to expose my fields as methods of that form, makes your class a quote Java bean.
Okay.
that's important because when Java first came out, there wasn't a way to reference a method on a class. So if you wanted to provide your own custom objects, like your own person class, an instance of it to some sort of library or framework that needs to dynamically pull data out of it, for example, Hibernate or Swing or anything else, there had to be a way to tell it, hey, like, this is how you get a hold of the name property on the class. So it can take the name property, convert that into the expected method using the same convention, and then use reflection to find that method and invoke it. So all of the objects in the bean pool, which is the interface itself is called a bean factory in the Spring source code, that's where the term bean comes from, is because originally when Spring was first popularized, the way it was configured is it would new up a class, and then it would call a bunch of setters on it to configure that class. So rather than the class going out and saying, let me go get my database connection string, let me go get my, data directory path, let me go get all these other values, they were pushed into the class, hence version control or dependency injection. Well, the dependencies were injected via the Java Bean specification.
Awesome. Yes, thank you. And that's some good background because basically every class that you make is going to follow that specification. That's how Java classes are written now, most of the time, or basically 99% of the time. Don't write a class not that way is my suggestion. Yeah. So that is why it's hard to differentiate the two, because at this point they really are basically the same. But that's awesome. Thank you, Paul. So we've covered what a bean is. A bean pool is just a collection of beans, so a collection of instantiated resources. And why that's important is because that's how Spring Boot basically drives everything. So when you start up Spring Boot, it's going to use all those opinionated defaults that we talked about earlier. Opinionated sensible defaults. And it is going to take those and use those to create a bunch of objects that it creates in the background when it starts up and adds those to the bean pool. Now, those objects kind of fall into one of two categories usually. They are either something that kind of gets used by default automatically, or they are something that is meant for you to be able to leverage using dependency injection. So there's probably some other categories as well, but those are the main two that they end up falling into when I work with them. Before we go into that, is everyone pretty familiar with dependency injection? Have we seen what that looks like before? Okay. Just because this is a recording, maybe someone's watching this that doesn't know what dependency injection is. Let's talk about that and singleton-ish patterns. If you don't know what a singleton pattern is, it is basically a way that especially enterprises used to organize code where it's like, hey, I have a class. I want that class to be responsible for doing these sets of things, but I only ever want there to be one instance of this class in my application. I don't want anyone to ever go make a new version of this class. I don't want any, basically it's you want to set it up, you want it to be configured a certain way, and then you want it to just be leveraged by everything, and you don't want anyone to ever accidentally like make another one and start accidentally using that's configured differently, if that makes sense. There were some less complicated and some more complicated patterns in Java to accomplish basically that. And Spring Boot kind of does that by default. The way a lot of Spring Boot stuff works is you are in a class and you want to use dependency injection. You say, hey, I know that somewhere in my bean pool, there should be a version of class X, which in this case, we're going to say this is a version of a service that converts, it's my number utility. It's my thing that can convert my numbers to strings or whatever. It is really kind of a bad example because that's not really configured a specific way. Instead, we're going to talk about a broker that calls out to a particular resource. Like, let's say that I want to call out to Google Drive and I want to grab a particular folder using the Google Drive API. Often you would see that there is one resource that is responsible for that, one class that's responsible for that. We are expecting there to be one instance of that broker class or whatever in our bean pool, and our dependency injection would say, hey, go grab a thing from my bean pool that matches this class, and it's expecting there to be exactly one of them. Bring it back, and then I want to be able to leverage that one that I'm expecting to be in my bean pool. We'll dig into what that looks like a little bit more in code later. However, the reason I put singleton-ish pattern is because that's the way it's used almost all the time that I see in Spring Boot. However, you can leverage multiple things of the same class in your bean pool, and it ends up being kind of cool if you want it to work a certain way, especially using interfaces. When you're doing dependency injection, you don't always have to just specify one thing. You can say, give me a list of all of the things that match this like interface. So if you've upped a bunch of different like event handler type things that all handle different types of events, you can dependency inject all of your different your list of all of those event handler interfaces. So if you've spawned 8 different components that all implement that interface, you get a list with all 8 of those instances back, and you can like use those to drive a lot of logic really, really easily that I have not been able to accomplish quite as well in other frameworks or languages. So any questions about the bean pool or anything along those lines? This is going to be easier to explain once we start digging into real code, but I wanted to just touch on it first because it is something I say a lot, and then people get confused why I'm saying the words bean and pool right next to each other so often.
I should probably mention that for people who are familiar with C#, specifically ASP.NET Core, the DI container that comes with ASP.NET Core is basically a copy of the Spring DI container in kind of the way it operates. Not in detail, obviously, but at this level, people who are familiar with either one of these, the other one is basically equivalent in every way. Slightly different names for things, but basically works the same way. It fills the same purpose in the overall design of the system.
Cool. Thank you. And DI in this case standing for dependency injection, correct?
Yes.
Okay. All right. So how do I get my hands on this magic? It's a great question. Start.spring.io is where I basically go anytime I'm going to make something. Usually it's a proof of concept, but honestly, the number of projects that have ended up shipping out to production that have started just by downloading a thing from spring.io is not negligible. So it's a really good place to start, basically for anyone. Let's take a look at Spring Initializer. So can you guys see that right now?
Could you zoom in a little bit?
I would love to.
On the big screen, thanks.
That help?
Yep.
Cool. So start.spring.io called Spring Initializer. They eventually changed the website because no one could spell Spring Initializer, which I was glad for because I always messed it up. But we're going to use this as kind of a framework of figuring out what different considerations do you want to make as you're starting up your Spring Boot project really quick. So let's start in the left side here. I'm gonna skip this one for just a second and come here. So first things first, language, right? We're talking about Java. This is the Java COP, so I won't spend a lot of time on the other ones, but Java runs on the JVM, which Paul and Sean gave us a great overview of the other day. And there are a couple of other languages that run on the JVM. There's more than a couple, but the two here are Kotlin and Groovy. I believe in my notes, what I have is language and version, Java, Kotlin, probably not Groovy, is how I would suggest, at least in the context of like the projects we normally work on. Don't get me wrong, I do love Groovy, but if you really want to write Groovy, just write Kotlin instead. Yeah, so that's kind of our language considerations. Like I said, I love Kotlin. Kotlin is mostly used in an Android space from a lot of people's perspective, but it is really, really nice that if you do want to write Kotlin and you don't want to write Java, you do have Spring Boot to back you up, and you can do all of the same things in Spring Boot with Kotlin as you can do with Java. It makes life so easy if you're wanting to play around in that area. Okay. So next thing, Spring Boot version, that's fairly self-explanatory. They do have some like more cutting edge versions, but just take whatever the last long-term supported one is. It's going to be best. 3, definitely start with 3. The upgrade between 2 and 3 is not particularly fun, and there are a couple of gotchas that people don't enjoy. So if you're starting with something, start with 3 plus, please. Yeah. Okay. Next thing here, our Java version. We talked about versioning a little bit. 17, 21. I wouldn't really go below those. No reason to, in my opinion. 21's great. What's the one that you just did all the virtual thread stuff on, Kyle?
That's 21.
21? Ooh,
Yeah,
do 21.
Spring Boot won't support. I think virtual threads aren't supported till 3.2.
Okay.
Spring Boot, but I think you could probably run it with 21 on.
Gotcha. I don't have Java 21 installed right now, so I'm not going to do that for this particular time. However, recommend Java 21. That'd be cool. All right, so here's the last thing that I wanted to call out, or not the last thing, but the last thing on the left side here that I wanted to call out that I don't think we spent a lot of time talking about in the past sections, and that is our dependency management or our lifecycle management system that we're using. So, Sean, Paul, did we talk about like Maven and Gradle or very much at all?
Only in that they're probably where you're going to get your jars or what you're going to get your jars with.
Okay. Cool. I mean, honestly, that's a large portion of the conversation. They accomplish the same thing. Gradle is a little bit more flexible. Maven, and you're going to be writing a lot of XML. So depending on how you feel about XML, which is not my favorite, then I opt for Gradle because I don't really love XML. But what you are basically doing is just same thing you would do with like a package JSON in NPM, or if you're using like Poetry in your PyProject TOML, you're declaring your dependencies and your versions. It's handling all of that for you in the background. The one kind of bigger difference is by default, it doesn't usually store this information inside your repository. So it doesn't store the libraries inside your repository like an NPM does. It is storing those more at like the user level in whatever system you're using, whatever OS you're using. And you declare your repository directory, and kind of that's where it puts everything underneath. It is technically possible to do that in the repo. And does the Gradle wrapper do that in the repo by default? I don't think it does it?
I don't think so.
No,
Okay.
Gradle wrapper. Well, Gradle wrapper is just a bootstrap to get Gradle installed.
Yeah.
The Gradle file will be specific, or the actual Gradle jar will be downloaded into the actual project you're working in.
Yeah,
But
the
then any
repo.
Gradle downloads will go to a shared folder in your user directory.
Yeah. Okay. Cool. I thought that was the case, but I second guessed myself right as I said it. So this is what Spring Initializer looks like. Let me go back to my slide and make sure I have not missed anything. Okay, so we kind of talked about all that stuff. Really, the big questions that you need to ask here is 2 things. One, how many out-of-the-box libraries do I want to use this time? Because that will change every time you do it. And 2, should I use Lombok? And I say yes. So you can take that as the gospel truth. Come here, we have all this stuff, and there's this big add dependencies button. You're going to click this button a lot. Out of the box Spring Boot, just like vanilla with no other things, like it's cool. It's probably not how you're going to use it. So let's talk about some of the ones that you will probably be using on 90% of your projects. So first one, like I said, most important, Lombok. I'll get into that in a little bit. It's really just an annotation engine that helps you cut down on a lot of boilerplate code for Java objects. It's not as needed anymore as it used to be now that like records and other stuff exist. But just so you know, I like Lombok. It's fun. It's only gotten me into trouble once. Dev tools are great. These are more just like nice to haves. You don't really need them. Has some live reload stuff. It doesn't usually work for me quite as well because I run things through the command line. But if you're someone that's like running stuff through your IDE, I think DevTools integrates really well with like the IntelliJ ecosystem. So it allows you to make some changes, hot reloads for you. You're good to go. I also like the configuration processor. It compares when you're like writing your YAML or your properties files, it compares it to a lot of the libraries you have installed and is like, it tries to do some autocomplete at the configuration level for you and also tell you like, hey, maybe you didn't mean to throw like an S in the middle of this configuration name. And you're like, yeah, you're probably right. I didn't mean to. Doesn't always work, but it's nice to have when it works. So those are all the development tools. Don't, like I said, not really needed. They're just nice to haves. So let's get rid of those. Let's talk more about things that provide functionality out of the box. So one of the ones that people want to use a lot is probably going to be anything with REST. So Spring Web. Spring Web's a super big one. That's how you're going to make RESTful applications, kind of like you were talking about earlier, Damu. Like I said, you're going to use this all the time unless you're building like a GraphQL API, or if you were using Spring Boot for something that's not exposing REST web services, that's totally fine too. But 99% of the projects that I start up are grabbing this right away. Any other thoughts on Spring Web at all?
I would echo that gets used a lot.
Stuff with like you had like the GraphQL support. I don't think it'll do much of anything if you don't also add the web support.
Oh, that's probably true.
So,
I mean, GraphQL,
if you're running a server of any kind, you basically have this.
Yeah.
GraphQL is just really a different payload format. It's still HTTP.
Yeah. There's a lot with the Spring Boot GraphQL library specifically that goes into more detail. If you guys want to know more about that, there is a recording of the Twitch stream from the user group where I did set up a project specifically for Spring Boot GraphQL. So feel free to take a look at that. Let's not touch it today because that's a whole other can of worms we can open. So that was Spring Web, Spring Reactive Web. Speaking of cans of worms, we're not going to talk about it a lot today. These are two separate libraries, technically. They can be used independently from each other, or they technically can be used at the same time. I will take a small detour to point out something I think is kind of important. There are particular objects, APIs, or whatever that Spring makes available for you to be able to consume REST services that you're calling, that you're trying to consume from your application, not make available from your application. In Spring Web, the default object or the default framework to do that is called REST template. And in Reactive Web, it is called Web Client. As far as I know, Spring as an organization is basically pushing people to say, hey, use Web Client. I don't think that they're doing a lot of upgrades to the REST template anymore. I think they're basically focusing all go forward stuff on Web Client. Is that an accurate statement, would you guys say?
Yeah, last I saw, REST template was like deprecated, kind of like what you're saying.
Yeah.
But they did, I don't, it might be in 3.2, but they added a new REST client interface that mimics Web Client. It's very simple. Yeah.
Because doesn't Web Client return monos?
Yeah.
From
it
everything?
does. Yes. Yep.
There's a new like REST client that I don't think does the mono stuff.
Okay.
I'd have to go. I don't remember. It's newish.
Yeah. So the only thing I would say as a consideration as you're looking at this is most of my projects when I'm starting out now, unless I'm committing to going reactive the full project, I'm grabbing both Spring Web and Spring Reactive Web, and I'm mostly just grabbing Spring Reactive Web for the Web Client library. You can use Web Client to consume the APIs that you want to call, and then just at the end, you can call block. It is functionally the same as if you were using like a REST template, even though when people see .block in your code, they're going to yell at you. Don't listen to the haters. Yeah, don't listen to Sean. But if you do want to go like and commit full reactive, which is awesome if you do, you only technically need Spring Reactive Web. If both Spring Web and Spring Reactive Web are found in the class path when Spring starts up, it will default to using Spring Web stuff. So it will, I believe it will still start up a Tomcat server instead of a Netty server, and it will still implement like normal blocking stuff by default for your REST services. It's not going to default to a reactive web type. That is something you have to opt into if both are on the class path. All right. That's all I'm going to touch on for reactive web right now. Again, can of worms. So we have Spring for GraphQL, which we talked about, but we're not going to talk about more. REST repositories, I'm not going to get into sessions. Yeah, let's not really touch on any of that for right now either. So here's another thing that's kind of at this web layer that is important. It's not used nearly as much anymore, but this kind of talks about a little bit of what you were talking about, Adamo. Timeleaf is a templating engine for Spring that is used to serve up like actual web visual content instead of just REST API or like API consumption data. Like I said, I wouldn't suggest using it heavily. I have in the past. It's not the greatest, but it's not terrible. But if I were to use it for anything, it is literally just to serve up the index page for a single page application that is now being written in React or some other framework in JavaScript, which is a little bit obnoxious, but has its place if you really need it. If you need like a bipod, I think pairing like Spring Boot mixed with a single page application together you could do worse. And Timeleaf is a really easy way to serve up that single page application from your Spring Boot server if you wanted to. Any other thoughts on Timeleaf? I know that word brings up baggage with me, and I'm sure multiple other people on this call. No? Okay.
I guess, so if you were to start up a project that involves like some huge application that needs a front end.
Yep.
Obviously, I know, kind of all that debate that goes, using React versus things that are not React, right?
Mm-hmm. Yep.
So putting that aside, what I'm hearing is you will totally probably not go the Timeleaf route. You probably use React.
Yeah, I probably would. Unless you really only need to serve up like one or two things and it's very, very lightweight and you don't need a lot of front end functionality. I would and am currently on like multiple side projects. I have all of my data is being controlled by creating APIs at the Spring Boot layer that is going to be a server running. And then my front end is all going to be a single page application in React is my language of choice or my framework of choice there. In my most recent cases, I just run like a straight up normal single page application that's going to be basically all client side, and then leverage identity providers and OIDC to be able to authenticate with my server and just do everything through that. Although if you do need to do more complicated logic, a lot of the times a bipod is helpful. Like I said, where you have a server that's consuming stuff, but I don't see as much need for it anymore as I have in the past.
I would add to a certain extent, are you doing templating versus single page app, right? Is actually the distinction.
Yep.
And if you're just serving a bunch of static HTML because you've got a report generation site, right? A templating engine like Timeleaf probably isn't a bad choice. But if you're, honestly, I think at this point, if you're even remotely thinking about anything interactive with JavaScript, just go full SPA and don't worry about serving out a bunch of intermittent pages.
Yeah, I would agree.
Of course, then we get into the whole discussion of single page server-side rendering, but that's
And
way
I
out.
Yeah.
mean, if you're just keeping up something quick and dirty, this probably works. But if you're doing it in like a real project, I think that if you're spinning out the single page application with React or whatever, you probably want that to be a separate altogether project.
Mm-hmm.
Like you probably want that deploying with its own pipeline and its own build process because there's no overlap in the technology between the two. So you're gonna be like building everything. You're gonna have tightly coupling two things together, and really it's like your single page application is a UI concern that could be consuming one of many APIs, and then this is just one of those APIs.
Yep. Yeah, it's basically like the balance I think Sean was talking about is really helpful. Do you want your like I think in all cases you're going to need a smart server somewhere that is like doing API type work, but is your front end dumb, like super dumb, and you don't need to do a lot of stuff? Yeah, use a templating engine. That's totally fine. It doesn't need to be very dynamic. If you want your front end to be smart at all, I wouldn't go that route. Cool. Adamu, specifically for like that type of question, let me know after this and I can point you to some things that I'm working on right now that will give you good examples you can look at for an API that's being done in Spring Boot plus a single page application that is all React that are interacting with each other using OAuth 2.
That'd be awesome. Thank you.
Yeah, absolutely. Okay, cool. So that was TimeLeaf. Let's get into the database world because that's a lot of the stuff from the front end. Like I said, Spring Web is going to be your thing most of the time. Now, my application wants to interact with a database as applications are wont to do. Spring JPA is going to get you 90% of what you want as well. Spring Data JPA. This is a Spring abstraction layer over an ORM. Which out of the box is Hibernate. If you've ever used Hibernate Vanilla, this feels much better to use than Hibernate Vanilla, in my opinion. But you do everything through annotations and classes. It's very Spring Booty. And you just point it at the database and you give it a couple of annotations. It's like, hey, it's this table. And the nice thing about Spring is because it has all those sensible defaults, you actually don't even need to configure a bunch of stuff. You just point it at the database and you name a class the same thing. You don't even need to give it the table name if you don't want to. If the class name and the table name are the same, it'll figure it out. It doesn't care. I appreciate that. Some people really don't appreciate that, but that's okay. Just know that is the case. With Spring Data JPA, you will be doing magic. I don't know the best way to explain that without showing you, which because it is 4:42 right now, we may not get to today, which is totally fine. That is maybe something we will dig into next session. But if anything in this world is magic, it is Spring Data JPA writing queries for you in the background just based on what you named a method. It's very weird.
And sometimes it will load far more data than you're expecting it to.
Yes. Yeah, we could do a whole session on working with JPA, which honestly I'm not against. I have a lot of lessons learned of doing things very poorly in that space that we could probably all benefit from. Okay, so at a database level, Spring Data JPA is great. The other two honorable mentions I would put out here are anything you want to use for versioning of your database is really helpful. So that is going to be something like a Liquibase or something like a Flyway. Please do not use both at the same time. That would not make sense.
Any sense?
But they are database version control. Basically, you write scripts with Flyway. I think it's usually like straight up SQL scripts. With Liquibase, you can write SQL or you can write like their own abstraction XML language that they then try and translate into the appropriate SQL depending on the database engine you're running against, which is sometimes helpful and was more helpful in the past. Now that you can containerize databases pretty easily and run locally against the same type of database you run against in production, I would recommend going that route instead of trying to do this like weird abstraction layer on top of your SQL. So Liquibase migration, Flyway migration, I'm not going to dig into those a lot, but they are very helpful and they make it really easy to just be like, yep, enable Flyway, point to this directory, make sure all those scripts are run and that my database is in good shape before my app connects to it. Any other database thoughts from anyone or like packages you like to use with databases and Spring Boot?
Is there like one of these packages that like stores HTTP sessions inside of a database or something?
There are, yeah.
Does exist.
Yeah, so okay, here this lets me like work backwards into a couple of other things I wanted to talk about. So this is not technically a data layer, but it could technically kind of be used as a data layer, and that is caching. Oh, sorry. There's also stuff for like MongoDB and things along those lines, but Redis specifically is one that I use all the time. Reactive Redis or Spring Data Redis. This is the one that I use a lot to do pretty easy caching. The more and more I build stuff, the less and less I find that I use it, just because caching is not always the answer. That is a different topic for a different time, but Redis is used a lot. Also, it can be used as a database. I've seen it used as a database. I don't like it, but other people do. So you do you. But this Redis caching is important because it does tie into some other storage things. So this is stuff kind of like what Paul was talking about. There's another one called Session, Spring Session. I have used this before in one of those bipod applications I was talking about. And it does work all right. Yeah, it's not like the best implementation of session management in the world, but it does get the job done, and it does support easily configuring that with a caching engine and just storing that session inside of like your Redis or whatever you're using to hold short-term cached information. Okay, this Spring Session probably only need like, if you're just serving up APIs, I would suggest going stateless for your session. If you are doing a bipod type thing, it would be helpful there, but probably not otherwise, in my opinion. Do other people have other experiences there?
I was just going to say with doing like OAuth 2 and chucking bearer tokens around all over the place, a lot of the stuff we just use sessions for, like, is the user authenticated, has completely gone away.
Yep. Yeah. Life is better now. If you just embrace the OIDC, life is better now.
I mean, people don't even know how much of a pain this was back in the dark.
Yep. Okay.
Make sure you land on.
So that's Spring Session, and then this brings me to my last big thing I want to talk about in terms of libraries. There's a wise man or person or whoever that once said, never ever implement security yourself. And they are correct. So Spring Security is a little bit obtuse to get into, but it is good. It does the things you want it to do. Use it. That's most of what I have to say in terms of like selling it. Everything else is going to be that configuring security is going to probably be one of the most obnoxious things that you do with a Spring library. So just kind of get used to that. And every couple of years it changes slightly, and you're going to have to redo all of your security when you do your upgrade. So I'm sorry about that. But it does allow you to put all of the different things you want on your different REST endpoints. There are about 7 different ways that you can set that up. Either all in one big chunk of code, or you can do some of it through configuration, or what I've opted to do in most of my last projects is I enable a thing called method level security, and I do all of it through annotations on the specific methods themselves. That way, who can access that method, like, and everything that they need to access that method is all directly with it, instead of off in this other file that no one knows anything about. So I will go more into that as we kind of build a project together ourselves, which I think that's what the rest of this series is going to kind of look like. After we go through this intro and what all this stuff looks like here, I will, at next session, we'll just create a project and we'll start making it. We can even have some kind of business logic that we want to go in to implement, and we can take a lot of these ideas and combine them together and see what these look like when they're actually implemented. Cool. So Spring Security, the other thing to talk about with Spring Security, and this goes more into OAuth 2 and OIDC stuff, is there are specific libraries for OAuth, and they're broken up into 3 areas here. The one that you will probably find yourself using the most is, well, actually both of these. OAuth 2 Resource Server is, I am an application. I have data that needs to be protected unless someone is logged in and like sends me a JOT, and it is good and valid and from a trusted source, and it allows me to check everything I need. This is what you want to do if you are protecting data based on what tokens people are sending you. All right. OAuth 2 resource server.
I can
Now-
think that's always pick this thing.
Yeah, pretty much always pick this thing. If you are serving up data, pick this thing.
You're
Now,
always in that mode. Always there.
now, if you are calling out to anyone and you are not passing along tokens that have been sent to you, or really, even if you are using OAuth 2 client. So if you are consuming a service that is protected by OAuth 2, you need to import the OAuth 2 client library. Cool. We will go into configuring those for different things and some different gotchas I've seen in this space as well. The other one that
Greg, you need Spring Security and OAuth 2 resource server?
you do need both. Yep. You need Spring Security to be able to use the OAuth 2 libraries, I believe. I think they leverage things that they expect to be in the bean pool that Spring Security spins up for you. So if you don't have Spring Security and you try and use resource server, your app will try and start up and it'll be like, hey, I tried to find this class in the bean pool. There's no instance of it. What's going on? Yeah. I'm like 85-90% sure that that's true, and I'm not lying to you, Paul.
Okay. It might be reasonably imported. I don't know.
Yeah, we can test it next time. Remind me and we'll test it. And then you have OAuth 2 authorization server. You're probably not going to use this unless you're using it for like a testing capacity, in which case there are a couple of other options I would recommend as well. But this is to make your Spring Boot application act as if it is an OAuth 2 resource server, or sorry, authorization server. Yeah, probably just don't do it, is my recommendation, unless you have a very specific need for this. All right, this does lead me to one last thing that's not security related. And you saw that when I typed in OAuth 2 that there is an Okta specific library. You will see all the time lots of different libraries that work with Spring Boot that you can bring in that are very specific to one particular vendor. Some people really love those. I hate them. I would much rather use the Spring abstraction layer on top of them unless there is a very specific reason not to. And the reason for that is that often with things like Okta, Okta is not the only auth server that you'll be working with a lot of the time. Maybe it is in production, but like locally, you might not have Okta to work with. In your dev, you might be able to want to run your app against Azure AD. You might be able to want it to run it against other things. I don't know. Using that abstraction layer is much more something I prefer. But you will see lots and lots of times there are vendor specific libraries. Approach with caution is my advice there. Like I said, some people really like them. If you can control your tool chain to be able to use those all the way up the chain and all the way through production and locally, great, go for it. Otherwise, just use an abstraction layer on top. They should all work the same.
One of the nice things about OAuth 2 is that by and large, there's a standard, and anybody that says they're issuing OAuth 2 stuff,
Mm-hmm.
if you plug if you plug the right 4 values into a thing that knows how to do JOTs, it will work.
Yes.
Yep. Think of like needing to break into like Okta would be like, oh, this server needs to actually go out and like create users. Like it's the sign up. It's like the account management for some public thing where somebody can go sign up.
Mm-hmm.
You need to make API calls to the Okta itself to like provision people. I can see that.
Yeah. The other thing is more specific to OAuth 2, and that is like what claims exist and what data is held in specific claims. It's supposed to be more standardized, but it's different depending on what auth server you're using. So it might make that easier. I'm not sure.
Yeah, you're probably one of your own class for that anyway, because you're probably custom claim with there anyhow.
Yeah. But cool. We are running very short on time. There's only like 6 minutes left here, so I'm going to stop here. I believe the last slide I had was just let's code. So let's make this appropriate for this particular thing. I was going to type not in the middle of it, but I'm in presentation mode, so I can't. So let's not code today. Let's code next time. And we will start off next time with basically going to spring.io, creating a project and getting it spun up locally, and then starting to build out some business logic that follows through with a lot of these things that we just talked about.
Woo!
That said, questions, comments, concerns.
But Greg, how much does this all cost me?
It's free, Paul. It's free. Yeah, Spring Boot, open source framework. You don't got to pay nothing. You will have to pay to run the actual stuff, but that is how technology works.
Why would you have to pay to run it?
You would have to pay for whatever you're running it on.
Oh, okay.
Yes,
So if you have
yeah.
your own server, you don't care.
Yes, yeah, correct. You would need to pay for the electricity to run that server.
Yeah.
Good question, Paul. I did not cover that. Any other questions or thoughts?
And also, people tend to forget about the internet. So that is also not free. In
That's
many
true.
cases.
That's true. Yep. You also need an internet connection. You need to pay for it.
Oh,
So
you
what
know.
we're saying is Spring Boot, very expensive.
You don't have to have an internet connection. You could run it
Run
up
it on local servers.
reach out anywhere.
I'm not ashamed to admit that what could have easily been like a Python or a Java script, just like one file, I have definitely just spun up an entire Spring Boot project to run like 2 lines of Java code. It is to the point where that pattern is so much easier than trying to write Java from scratch out of the Spring Boot environment. For me anyway, that makes more sense to me sometimes. It is not a good use of resources.
I'm even worse. I will then take that Spring Boot project and wrap it in a Docker container.
Yes, yep, yeah. And wrapping Spring Boot projects in Docker containers is extremely easy, which is nice because they do already come with like the server and everything that they're running on. It's usually just building and then just popping over your jar or your war or whatever it is into your container and then setting some Java options and you're good to go. Awesome. Thanks everybody. Like I said, we will build something next time. It's going to be fun. Bring your computers and we will like all do it together if we want to, which will be cool. Until that time, if you have any thoughts or questions, let me know. Adamu specifically, yeah, definitely reach out because there are like 17 different ways to do exactly what you're talking about. And I've done 18 of them. The last couple I've settled on, I feel like I like the best. So